Lesson 6. Here we got to start talking about the data distribution, or the distribution of the data. How does that come out when we look at all the values and different things that are there? This goes with our statistical part and our probability part together because it kind of combines both of them. It starts to give us the percents and our probabilities of something happening with some statistical data that we need to use with it. So let's get started on this, shall we? Okay, the first thing to talk about is discrete probability distributions. That's what we've been doing, is discrete probability distributions. Everything's been pretty finite, right on the lines. No things out there. There's also what's called continuous probability distribution. And these are when we start to look at if we had a ton of information. So the very first thing I want to show you is this little graph right here. Sometimes it's referred to as the bell curve because it kind of looks like a bell. Okay? Now, this is what we consider normally distributed information. All the data is placed on here, and this is what's called a histogram. So if we took all that data and put it on this histogram, and we graphed it out, this is kind of how the top edge of all that data would line. There'd be pieces on very end, but most of the stuff is all right there in the middle. Okay, so now there are some other things that happens with this. We can end up with skewed distributions. There could be negatively skewed distribution or positively skewed distribution, and this depends on where is the tails at. So when it's negatively skewed, notice there's a bunch of data on the very, very left. Not too much on the high end, a lot on the low end, negatively skewed. Positively skewed data says there's a lot of data all the way out to the very end. There's a lot more little pieces together in there. So those are the two things. We're going to have to be able to take a set of data and determine is it negatively skewed or positively skewed ahead of time before we deal with some of the others. Now, let's talk more about this normal. No, let's go ahead and do that. There we go. So here I have 3 data tables, and I just want to know, are they positively skewed, negatively skewed, or normal distributed? Well, the first thing I want to look at when I look at any one of those, so we'll start with this first table. Okay, so the first thing I look at is these values here. Are they all equally spaced? Yeah, they're all about 20 units wide, 19, 20 units wide, which works real well. And I notice I have some modems, but notice here it just keeps adding more on and on and on and on and on. So this is positively skewed. So if I made the graph of it, it's going to look like this graph. It would have that big bump, and then it kind of falls away all the way out to where the 100 is. Okay, so let's look at the middle one. Again, I look down the first column here to make sure those are all basically the same width. They're all about 15 degrees, which is good, and there's no overlap. And I notice went from 4 to 12 to 19 to 12 to 2 to 1. That's pretty normal. It's kind of symmetrical. Both ends are about the same. So I would say this one is normally distributed. Distributed is getting the R in the wrong spot. Okay, last one. Again, I look here. All those values are about the same, about 0.4 units, or about that, 0.5 units. And now as I look at numbers, but here's my high value, and then it's a little lower, but then so here I've got all these things skewing it here. So this one is negatively skewed. The bulk is here, and I got all these values on the negative side of it, pulling it all down. That's what makes it negatively skewed. Okay, so now let's talk more about the normal distribution. A normal distribution has these properties. The graph is maximized at the mean. The mean, the median, and the mode are all about the same value. They're all real close together. And then when that happens and you get this nice little curve, here's my mean, and here I have a mark, and here I have a mark, and a mark, and a mark, and a mark, and a mark. Each one of these is a standard deviation, like we were talking about in the last lesson. One standard deviation. Here's 2 standard deviations now. And now we're out to 3 standard deviations. So as it tells us here, about 60% of the values are within 1 standard deviation of the mean. So if I have the mean, and I calculate the standard deviation, and I added and subtracted that from the mean, that's how far 68% of the values are going to be. 95% of the values are going to be within 2 standard deviations. So from here to here, we account for 95% of the data. And then when you get all the way out to the edge, 3 standard deviations out, you've accounted for 99% of the data. So almost every value is accounted for in that range. So when we look at this normal distribution, and we see this distance from here to here is 1 standard deviation. One of those square roots of the mean of the differences of all these values from the mean. That's what we're looking at. That's how far it is. That's why that standard deviation was so important that we were able to calculate it. Okay, so let's see a problem that's going to deal with this. Okay, the shelf life of a particular dairy product is normally distributed with a mean of 12 days and a standard deviation of 3 days. So the first thing I like to do is I bring in a bell curve. I look at a bell curve, and I take the information that they gave me. Well, they told me that I had 12 days as a mean. Now, a standard deviation of 3 days. That means the distance between each one of these dotted lines is 3 days. So add 1, I get up to 15 days. Add 1, I get up to 18 days. Add 1, I get up to 21 days. Okay. Now, if I go the other way, I got to subtract. 12 minus 3 is 9. That's 1 standard deviation down. 6 and 3. Okay, so that accounts for all these values. Now, below 3, that means there's 0.5%. Above 21, there's a 0.5% that there's something there. Okay, so now I can answer these questions about what percent of the products last less than 3 days. Well, here's my 3 days. There's my percent. About 0.5% of the products are going to last less than 3 days. Now, let's say we had 500,000 products. That we were studying here that all had this 12-day, 3-day deal. So if I had 500,000 products and 0.5% of them were going to last less than 3 days, I'm going to take 0.5%, so that means 0.005, and multiply that by 500,000. And I get about 2,500 products would last less than 3 days. Out of that entire 500,000, 2,500 of them wouldn't make it. Okay? About what percent of the products will last between 9 and 15 days? Well, 9 and 15 days are 1%. I just add these 2%. That's 68% of them. 68%. Okay, so if I'm talking my 500,000, we're talking 340,000 of these products are going to last between 9 and 15 days. That's pretty good. About what percent of the products will last between 12 and 15 days? Between 12 and 15 days, that's just between here and here. That's just this 1%. That's for 34%. So if I did my 34% down here, I get 170,000 of them are going to be at mean or just a little above. Okay, and then what percent of the products last more than 15 days? Okay, more than 15 days. So I start here and I add up all of these percents. And when I do that, I get 16% of the products are going to last that way. So if I had 500,000 products and 16% of them are going to last more than 12 days or more than 15 days, I'd get about 80,000 products lasting more than 15 days, who are supposed to have a mean life of 12. So that's normal distribution and some of that skewing stuff. When they're skewed data, we can't really do a whole lot with them. But when they're normal distribution, we can use this little graph right here that shows kind of the percents, and we can use that information for us. Now, there is a way to actually calculate each of these percents down specifically, and we might look at that, or I might just save that for another year of school for you. So that is our distributions. You're ready for this assignment.